Welcome to Chapter 6, ROS Basics. In this chapter, we will explore some of the basic concepts and tools used to create ROS systems. Understanding the structure and organization of these systems is a prerequisite for developing ROS systems of our own, which we will be doing as soon as we get the basics out of the way. Okay, so box 6.1 reminds us that we need to install ROS first. See resource 1, which is at the end of chapter 5. So go ahead and go back and check out resource 1. Make sure your installation is working with ROS Melodic, Ubuntu 18, etc. So make sure you follow that so that things will work in the preceding lectures. Okay, so lecture 6.1 is ROS graphs. A ROS graph is a graph, a la graph theory, representation of a ROS system, such as that of figure 6.1. Okay, so we got this 6.1 figure right here. Graph nodes, okay, so graph nodes are the green boxes, represent ROS programs running on potentially different machines. So for instance, the program foo, the program bar, and the program baz could be running on different machines, or they could be running on the same machine. Graph edges represent the peer-to-peer communication of messages among nodes. So messages are what's being passed back and forth among these nodes. So foo is sending messages to bar is sending messages to baz is sending messages to bar, etc. Okay, so that's basically a ROS graph, ROS. Anyways, it's pretty straightforward, and hopefully you're familiar with some graphs of graph theory with nodes and edges, and that sort of graph structure will make sense to you. Big Other ROS core. Jacques Lacan introduced the concept of the Big Other, who is, among other things, the virtual repository of all knowledge, the invisible guarantor that the network of symbols is consistent, and the registrar of the symbolic. Okay, so he's a psychoanalyst, philosopher guy, so I put a little reference to him, and you can look him up. I thought this idea of the Big Other was useful for this part of the text here. The Big Other of ROS is the communication service ROS core. Okay, so core here is the operative word, core. All nodes of a ROS system register the message streams they provide and those to which they would like to subscribe. Okay? Everything registers this with ROS core. These message streams are organized by topics. A node that publishes information for other nodes does so by registering a topic with ROS core. ROS core maintains lists of these topics and subscribers thereto, and provides these details to any node upon request. If node foo publishes to a topic X, subscribed to by node bar, foo would find out that bar has subscribed, then would directly transmit messages to bar on topic X, as shown in the figure below. So we have foo, it publishes topic X. It would talk to ROS core. It would find out from ROS core that bar is subscribing to topic X. Foo says, well, I publish to topic X, therefore I will send bar every message on topic X that I publish. So that's how the sort of structure works. So they do check in with this ROS core to see who should be getting it, and then the topic that gets published goes to every node that has subscribed. Thus, big other ROS core is virtually in all ROS graphs, required for its existence, but we don't include it explicitly. So we didn't put like ROS core up here, even though technically it would be required in every graph. We just have it in there in the background, and we never actually include it in the graph explicitly. We must launch a ROS core service for every ROS system. Doing so is trivial in a terminal window as follows. Just enter ROS core. So let's do that. I have my Ubuntu virtual machine up and running. I have a terminal open, okay, and I just type in ROS core, enter, and it'll start up a ROS core service, and it has a default URI that this port, it always is defaulted to. You can change that, but it's easier just to use the default. And that is how to start up a ROS core service. Fortunately, we don't have to remember to do this manually every time, as we'll see when we discuss ROS launch in lecture 632. So if you want to shut down your ROS core service, as with virtually everything in the bash shell, if you want to stop what process is happening, Control-C will do that for you. So it'll kill the process and shut it down, and then you're done. So now you're back to your bash terminal, your bash shell. So that is ROS graphs.